Hi everyone, in this video I'd like to talk about plotting parametrically defined functions and polar plots here in Maple. So suppose we want to plot a parametric function like x of t equals sine t and y of t equals 2t times cosine of t. Now notice that we've got x and y coordinates, so in that sense it's similar to plots we've done in the past where we are plotting a bunch of points in the xy plane. But what's really different here is that x is a function of t and y is a function of t. So I think it's really helpful to think about t as being time. And as time goes by, the x and y coordinates, the position, are being defined or dependent upon t. So let's start off with a plot. Notice that I've used the plot command. I'm in math mode and I have square brackets. So this is what the curve looks like. Now I mentioned that this curve is dependent upon time. To really emphasize that, I'd like to do an animation. To do that, I'm going to incorporate the plots package, so I need to call that up. And then I'm going to animate the plot. So what I've done here is I've animated the plot. There's a bunch of square brackets before and after the actual definitions of my plot. So I've got the function here, and then I've got my time parameter going from 0 to a, where a goes from 0 to 4. And the reason why that's helpful is that then that parameter a is what allows me to animate the plot. So I'm going to click on the plot. It looks empty at the moment, but at the top here there's a play button. And as time increases, or my A increases, I can see that curve being traced out. And you could always increase time. I could maybe go up to 8 pi here. Click on the plot and then click on play. And now I can just watch what happens to this curve even more time goes by. And so this is really helpful for looking at the direction of travel along these space curves. Let's take a look at a polar plot. If you want to do a polar plot in Maple, you also need to call the plots package. I've already done it, so I don't need to click that again. And here, polar plots are given by defining an angle as measured from the positive x-axis and then a radius of how far out away you are from the origin. And again, this sort of spiral shape is not a function in the xy plane, right? It would fail the vertical line test. But in terms of a polar function, it certainly is a function, and polar coordinates are very helpful for modeling these types of phenomenon. The animation here is quite fascinating. It looks like an empty plot, but again, if you click on the play button, you can watch that spiral being traced out as time increases.